Let's get started. Let's start by stating Coulomb's law. Coulomb's law states that the force of interaction between two charged particles is directly proportional to the product of the charges and inversely proportional to the square of the distance of separation between them. We go again. The force of interaction between two charged bodies or particles is directly proportional to the product of the charges and inversely proportional to the square of the distance of separation between the charges. Coulomb's law, as I have stated, can be split into two. One part says that the force of interaction between two charges is directly proportional to the product of the charges. And let's do this. Let's see. And then let's look at this. Look at these charges. The red charge body has a value of 8 microcoulombs, while the blue charge body Q1 has a value of minus 6 microcoulombs. Look at the force of interaction between them. You can see that the force on Q1, the force exerted on Q1 by Q2 is given as 479.336 Newton, while the force on Q2 exerted by Q1 is equal to 479.336 Newton, the same thing like the force exerted on Q1 by Q2. So these forces are equal. Now let's do something. Let's say that I increase the charge on the body because Newton's law says that the force of interaction is directly proportional to the product of charges. What that means is that if the charges, the quantity of charge on these charged particles, Q1 and Q2, increases, now the force of interaction between them is going to increase. So let's see what happens. Okay, on this Q1, let me increase the charge to, let's say, minus 8 microcoulombs. Q1 has been increased from minus 6 microcoulombs to minus 8 microcoulombs. You can see that the force of interaction between these Q1 and Q2 has increased to 639.115 Newton. Okay, so if I also increase the quantity of charge on Q2, it is on 8 microcoulombs. Let me increase it to, let's say increase it to 9 microcoulombs. You can see that the force of interaction between them is now 719.004 Newton. So this proves that the force of interaction between two charged bodies is directly proportional to the product of the charges. What that means is that as the quantity of charges on charged body is increased, provided the distance is constant, the force of interaction, the force they exert on each other is also going to increase. Okay, so I return these charges to 8 microcoulombs and minus 6 microcoulombs. Okay, another